All right, day 15. We have a grid and some instructions, and you want to know the sum of the coordinates after it moves, and there's a robot that's gonna move and multi-push boxes, presumably. Okay. Okay. Uh, okay. Times. Uh, Twice as wide. Okay. Does the double push work? Would cause it to move into a wall. Nothing moves. Okay. Nice. That went really well. Okay, so what was going on today? So we have this grid problem. So we have a robot moving around in the grid. We have walls and we have boxes. And then we have a set of instructions for the robot to follow, which is left, down, up, or right. And so we want the robot to move around and like push stuff as it goes. Uh, so, for example, and it can push as many boxes as it wants, but it can't push anything into a wall, right? If it tries to push anything into a wall, just nothing will happen. Also, if it tries to walk into a wall. So we're supposed to simulate sort of all these movements and then calculate, I don't know, some sum of the box coordinates basically then to prove that we moved all the boxes correctly. So, here's where the boxes moved after my input. Um, so what are we doing here? Okay, well, so that's part one. And then part two, everything, but notably the boxes, are twice as wide, which complicates the pushing situation a bit. They give the example that you can have one box pushing two boxes. And also, like, still, like, if you push this up twice, the second one won't go through, even though this one can move. This one can't move it to a wall, so it wouldn't get pushed. But, like, a single push, instead of just moving, like, a line of squares, it could move a whole, like, triangle of cells, potentially. So that's more complicated. Um, So I believe if I comment out all of these lines, I should get the answer to part one still. I get 0. Because in part one, the boxes are represented differently. Now I get 1, 4. Oh, I got a wrong answer. Really? Oh. Yeah, I need this. Trying to modify my code to handle both parts. So I need to deal with the fact that part 1 and 2, the boxes are like different things. 1, 4, 1, 2, 9, 7, 1. Okay, cool. So this code does in fact, well, sort of handle both parts now. So I'm gonna like write a solve function and call it twice that just does all of these steps. I think I screwed up at least one of these. Um, for 12971 and 1429299. Nice. So this does solve both parts now. Okay, so what is actually happening here? So in part two, we're like doubling the grid the way that they told us to. So hash turns into double hash, O turns into like a big box, dot turns into two dots, and the robot turns into a robot and a dot. And of course that doubles the number of columns. So first we figure out where the robot is, and then we go through each instruction. There are new lines in the instructions for some reason. So we figure out, like, we convert the instruction into a direction. And if there's a wall in that direction, we do nothing. If there's a dot in that direction, then we go there. And if there's a box in that direction, then we need to do a complicated pushing logic. So a box could either be the left side of a box, the right side of a box, or the whole box in part one. So we're going to figure out like what squares would be pushed by this move, and also if any of them are being pushed into a wall. So we start with a robot that's like sort of getting pushed. And then we do, I guess, yeah, it is a BFS. We do a BFS to figure out like what squares get pushed. It's kind of a simple BFS because it's only in one direction. So if if you've already seen this square, do nothing. I think this actually doesn't happen because we're only going in one direction, but whatever. Keep track of the squares that we've seen. Those are the squares that we're going to need to push. And then if we run into a wall, then we're not going to do this whole pushing operation. So just exit out early. If we run into a box, then we should push it. If we run into the left side of the box, then we should push it, and we should push the right side. And if we run into the right side of the box, we should push it, and we should push its left side. I guess maybe to be more clear, I could say, assert that this other side is actually, the left or right side of the box. This is a -1, this is a +1. Okay, so this gives us all the squares that we would want to push, right? That whole triangle in the, sort of interesting case in part two. And also it tells us if any of them hit a wall. So if any of them hit a wall, there's nothing to do. If none of them hit a wall, then we need to push them. And so I guess an important point here is we don't want to like push this box first because then we're going to lose what was on this square. So what I'm doing is just like iterating through this list many times, sort of checking the square, above it or in whatever direction we're pushing in. And if that square is not a square that we need to push, then we can push to it because we're not like losing any information in the grid. Like we sort of, if we're pushing up, we want to push the like top thing first. So I was initially thinking I would like sort by the direction that we're pushing, but it's too complicated. It's easier to just like do this loop. So anyway, if we are pushing onto an empty square, then like do the push. So that square becomes our thing. Our thing becomes empty, and we can remove the thing that we're pushing. And we mark down that we actually we don't need this. Fine. I mean, we don't really need this either, I think. Whatever. So anyway, push all the boxes and then move the player because this was a successful move. So that's it, I guess, right? This is the complicated case where we're actually multi-pushing boxes. And then after we've done all the moves, we can go through all the boxes, and it says to measure from the top left. And that means that the left side of the box is always the closer one to the top left. And it says that the score for a box is 100 times the row plus the column. So fine. So add that all for all the boxes, and that's the answer. So yeah, that's it. I guess the complicated bit for part two, I think, is definitely handling the multi-pushing. The multi-pushing is kind of complicated in part one because you need to push a whole line. So I don't know. Maybe this is a simpler way of doing it than this, but I think this worked like pretty well. And especially, this is a nice way of not pushing boxes like on top of. But you need to push them in an order that they don't like crush each other, kind of. And it's nice that I don't really have any like direction. It's not like I have 4 copies of the code for the 4 directions, right? That's kind of nice. Okay, anyway, that's it for today. See you tomorrow.